Alright, guys and gals, as you can see, I am not here yet again. This time is because I'm on a freshman retreat. I swear, I'm your actual teacher. The substitute is not your teacher, I promise. So, here's what we are going to do today. First, you're going to watch this video and fill in your foldable notes for lipids and nucleic acids. Once you're finished with that, you take your notes up, show the sub, and he will give you a worksheet where you only have to do numbers 1 through 23. Only numbers 1 through 23. So, here we go. Flip to your lipid section in your foldable, and we're going to get started. Alright, so we have flipped to our lipid section, and the first thing that we notice is that lipids are molecules composed of carbon, hydrogen, and oxygen. So, remember, just like last time, if you know what the symbols stand for, you can write those out instead of the actual words. So, carbon is represented with a C, hydrogen is represented with an H, and oxygen is represented with an O. So if you don't have enough room, or you like to write the symbols instead, C, H, and O. Also, it says they are insoluble in water. Insoluble is going to be one of your key words. Very important, which means it should get, that's right, a star. Okay, so make sure you put a star next to the word insoluble, and let's talk about what that means. It says, insoluble means that lipids do not dissolve in water. Lipids are what we call non-polar. Now, in class we have talked about how water, H2O, is what we call a polar molecule. Polar means it has its good ends. So remember, happy starts with an H, just like hydrogen, so our hydrogens are positive. And it also has its bad days, which means our oxygens have to be negative. Polar things only like other polar objects. So that means that lipids and water will not mix together. Polar likes polar, non-polar likes non-polar. The next bullet point says lipids can be used to store energy. And our third bullet point says lipids come in 4 major categories. We have fats, oils, waxes, and steroids. So, the first group that we're going to look at are the fats. Fats have 2 regions. The first region is called a glycerol molecule. So that's the first thing we're going to write down. And then the second part is 2 or 3 fatty acid tails. So on your paper, if you look above where you're taking your notes, you can actually see this picture right here. Okay, and on the side, you see your glycerol, and then you see fatty acid 1, 2, and 3. Now, when a fat has 1 glycerol and it has 3 fatty acid tails, it is called a triglyceride. And the reason it's called a triglyceride is because the prefix tri means 3. So that refers to our 3 fatty acid tails. And the ending glyceride refers to the fact that there is a glycerol molecule that they are attached to. Now we're going to go more in detail to the group that we call fats. So there are 2 major types of fats. The first type of fat is called a saturated fat. And I just want you guys to take note for now. Saturated starts with the letter S. And that's going to be extremely important when it comes to the end of this slide. So, the first bullet point states that saturated fats are composed of fatty acid tails that only have single bonds. And what letter does single start with? Why, in fact, it starts with the letter S. Isn't that interesting? The second bullet point says all of the carbons in the fatty acid chains have the exact number of hydrogen atoms that they need. So this means that a carbon is satisfied by having 4 bonds, and at the end of each one of those bonds, you should be able to find a hydrogen. That makes it happy. Okay? The third bullet point says the fatty acid tails are all straight chains. How interesting again. Look at that. The word straight starts with the letter S. How ironic. And then the next bullet point, we have another S word. These fats are solids at room temperature. And examples are animal fats like eggs and meat. So, the way for me to remember saturated fats is I remember S cubed. So this is something I would put in your notes in the side margins. Saturated fats, so that is our original S stands for saturated, have 3 special properties, are cubed. The first special property that we're going to refer to is the fact that saturated fats only have single bonds. So the first S stands for single. The second property is that those single bonds help us to form straight, so that's your S, straight chain tails. And then our third property that also starts with an S is that saturated fats are typically solids at room temperature. So again, I would make sure that I remember S cubed. I would write this somewhere special in your notes. The second group of fats are called unsaturated fats. So when you think about these, you can think that unsaturated fats are basically the opposites of saturated fats. Unsaturated fats are composed of fatty acid tails that have at least one double bond. They are bent chain tails, and they are liquids at room temperature. So these are your olive oil, your peanut oil, your canola oil. So, as a reminder, I would find some more open space and I would create a T-chart. Just like this. Okay, on the one side of the T-chart, I would write saturated. And on the other side of the T-chart, I would write unsaturated. Now, under each side of my T-chart, I would also put the characteristics from before. So remember, we would write S cubed. So S cubed. The first thing we would write is that they have single bonds. The second thing we would write would be straight for our straight chain tails. And the third thing we would write would be that they are solids at room temperature. Now, if saturated are all of these characteristics, unsaturated has to be the opposite. So instead of them having single bonds, they would have double bonds. That's right. I know you said it in your head. Instead of having straight chain tails, they would have bent chain tails. Kudos to you. I know you had that answer. You definitely would have raised your hand if I was there. And the last one, instead of being solids, our unsaturated fats are liquids. We did it. We made it to our last group of lipids. We have the steroids, the waxes, the trans fats, and the phospholipids. So, the first group we're going to look at are the steroids. Okay, now, we're not specifically talking about the ones that people inject illegally. We'll save that conversation for another day. Okay, here we're talking about the ones that are hormones that serve as chemical messengers. And the big one that you need to make sure you have written down is cholesterol. Okay, now cholesterol has more than one purpose. You've probably heard of somebody having high cholesterol. That means that they've consumed too much and it's clogging up their arteries. But cholesterol is also going to become extremely important when we start talking about cell membranes. It allows for the cell membranes to be what we call fluid. Our second group of lipids on this slide are the waxes. And the waxes are used as protection and waterproof coverings. So, I want you to write down at least one of the following examples somewhere in your foldable. The first type of wax we're going to talk about is one that I'm sure you're all familiar with. Good old earwax. Ew, gross, Miss Cissell. Okay, earwax is actually extremely necessary for you because one, it keeps water out of your ears. So, remember before we talked about how water is polar and lipids are nonpolar? This means that they do not like to mix. So, when water tries to enter into your earways, that wax creates a covering so that it doesn't make it all the way into your head. We also need earwax as a buffer. So if you're at a concert and you're listening to really loud music right next to the speakers, the earwax also absorbs some of the sound that's coming through and it protects your eardrums. The second type of wax that I want you to know about is called a cuticle. Now, I'm not talking about the cuticles on your nails, ladies, that sometimes give you a hangnail and they're painful. I am talking about the outer covering on the surface of a leaf. If you've ever picked up a leaf and you felt it between your two fingers, you'll notice that it has a waxy coating. The reason that's there is so that water does not escape the plant and plants can easily do photosynthesis. The last group of waxes that we're going to discuss, or that you can write down in your foldable, is blubber. Now, blubber is found in lots of animals, especially whales and other animals that live in the Arctic. It's there as a protective covering that actually allows for them to maintain their body heat. So that's why a whale can go swimming in the Antarctic or the Arctic Ocean without having their body temperature drop too drastically. The next group we're going to discuss are the trans fats. Okay, and these are the ones that you find on chips. They say no trans fats included. These are oils that have been what we call hydrogenated. Hydrogenated just means that hydrogen atoms have been added to it, turning them into solids at room temperature, a state where they usually are not. And the last group, this group is going to be the most important. This one deserves a big old star. These are called phospholipids. Now, first write down the two lines that have been bolded and underlined for you. You need to know that phospholipids are components of cell membranes, okay? And you also need to know that they have a polar head and non-polar fatty acid tails. Alright, so last time, find one more open space on your foldable, and this time we're going to draw a picture. A phospholipid, as we just stated, has what we call a polar head, so we're going to start by drawing a circle. Okay, this is called our polar phospholipid head. Now, polar means that it likes water. So we can also call this portion of our phospholipid hydro, meaning water, philic, meaning loving. So if something is hydrophilic, it is water-loving, just like the polar head of our phospholipid. The second part of our phospholipid is called the non-polar fatty acid tails. So we are going to want to label these guys as well. So let's draw ourselves an arrow. Non-polar phospholipid tails. Now, we said that anything that is non-polar does not like water. As a matter of fact, we say that the tails are afraid of water. So we call them hydro, again referring to water, phobic, meaning afraid of. So if you are arachnophobic, you are afraid of spiders. This is all for the lipid section. If you have any questions, make sure to write them down somewhere safe or type them up and send them to me in an email so I can make sure that I can answer them. Once you have the section completed, you'll leave this video and you'll enter a new and exciting one all about nucleic acids. I can see the smiles on your faces all the way from freshman retreat.